This is my 12th video in my series on using Google Sheets to do inferential statistics by simulation. So far in this little sub-series on using categorical data, we've looked at the questions from the July 2018 Pulse of the Nation survey. Do people agree or disagree that nobody deserves a free handout from the government? And do they think the government should do more to help small working class towns in America's heartland? Interestingly, 270 people somehow managed to agree that the government should not give handouts, but they should help small towns. And 32 people disagree. They think the government should give handouts, but not to small towns. So these 302 people seem to be a little bit confused and inconsistent. These people, on the other hand, these 286 and these 87, are at least consistent between their responses. Anyway, in this video, what we're going to try to do is visually graph the difference between the two proportions, the proportion of people who agree who say yes, the proportion of the people who disagree. This is going to be very similar to video 4, where we did the same thing with averages instead of proportions. So these are actual proportions. We also need to look at something called the standard error for these proportions. The formula for the standard error is the square root, which in Google Sheets is squirt, S-Q-R-T, of the proportion, I've got this proportion here over in box E10, times the proportion, the complement of the proportion, 1 minus box E10, divided by the total number of people in this sample, which is, the total number of people who said agree, which is 357. Close out that square root. So there is a margin of error of about 2.2% for this group. And for the people who disagree, slightly different proportion, again, equals the square root, the squirt of my proportion here in box E11, times the complement of my proportion. This is P hat and this is Q for those keeping track. 1 minus box E11 divided by the total number of people in that group, which in this case is 318. Close parentheses, enter. A slightly tighter margin of error. Even though there's fewer people in the group, the higher proportion, the smaller the margin of error tends to be. Now I want to graph this. I could just highlight these and go insert chart, but if I do that, I tend to get a pretty janky chart that makes it impossible to give different standard error bars for each of these two, and they do have different errors, so this really isn't going to work for me. Instead, I'm going to do this little hack with Google Sheets. I'll put the agree here, I'll put the disagree here, and then weirdly, I'm going to type that again here and here, because I want to convince Google Sheet that these two numbers, this 0.7563 and the 0.8993, I'm going to type that over here. This is the way I convince Google Sheet that these are different series. That rounds to 4, not that it's going to matter. This convinces Google Sheets that these are actually different series, and it'll let me input different standard errors, 0.022 and 0.017 once it's rounded. Insert chart. Now, it doesn't necessarily look as nice, but this is actually better because it will allow me to give them different standard errors. I'm going to make it a vertical bar chart. I like that it starts at 0. That's good. I'm going to go customize series. I'm going to select just one series, the agree. I'm going to give them error bars of a constant value, and that constant value we said was 0.022. There they are. Then I'm going to go over to the disagree. I'm going to give them error bars. They're also going to have a constant value, and theirs was 0.0168 or 0.017. Now each of these have different and appropriate standard error bars. I could do a little bit of fine tuning with where these headings go to make it all line up nice. I could get rid of this legend at the top that isn't really adding any information at all. Clean my graph up a bit, but this is how I make a graph of two different proportions with the correct standard error bars for each.